Hi, this is a recording for the last homework assignment, and let's go ahead and start with the zip file. And there we go. Hi, this is a recording for the last homework assignment. We will start with the zip file. So I'm going to put it into a temp folder, and it will work from there. All right, there you go. So I'm just using a text editor to do everything here. So let me zoom this, too much. There we go. All right. And here's the individual files. So it's good to keep an eye on the C file and the TTP-ASM on the other side. So we'll go ahead and display both side by side, like so. And now we can start to work on it. Main is already done, so we just have to focus on traverse. And on this side at the bottom, we have the template for traverse. So typically, I just like to display what is on the stack at the time. So we get array, which is a pointer to an unsigned integer. And then we also get PTR, which is a pointer to a struct node. And then we have the return address, which is what the stack pointer should be pointing at the entry point of traverse. Okay, so the first thing we need to do in traverse is to access pointer. So this is kind of like a universal thing, unless we are dealing with global variables. If we're trying to get to a parameter or a local variable, we have to start with the stack pointer. And we don't want to change the stack pointer, so the best way to do it is to copy the stack pointer to some other register, and then we compute the address of the thing that we want to access. So in this case, at this point, C is the address of the return address, which is not what we need. But one increment, and C now becomes the address of PTR, the first parameter. But we don't really want the parameter itself. We don't want the address of the parameter. We want the actual parameter. So in this case, we do need an LD instruction so that A is now PTR. Both the LD instruction and the ST instruction would do indirect or dereference because of the parentheses. So it's kind of like a syntax to help you decide, help you understand when we are dereferencing. Whenever we use parentheses, we are dereferencing. All right, so now that A is loaded, we can now check with this. So and AA is kind of like test register A, and it will update the Z flag as well as the sign flag. The Z flag is what we need, so we do a JCI to end if in this case, and then we'll put end if down here, which is about to exit the program. So if we are not doing a branch to end if, that means PTR is non-zero. So I'm just gonna put it down here. Okay. First thing first, we have to call traverse again recursively, and we have to pass array. Now, because I have register C still pointing to PTR at this point, I can just increment it once. Okay, so increment C, so that register C is now the address of array. We don't really need array, so we'll do a LDAC. Yeah, let's put it into B because I can use A again for other things at this point. So I put, indirect C into register B. So the B is actually array, which is not what I want to push on the stack. So at this point, we have to indirect once. So that B is the address. Oh, okay, never mind. Array is in fact what I want to push on the stack because the parameter is specified here. I was already thinking ahead of the next line, so never mind. It is actually just that we need to push. So now we just need to decrement the stack pointer and do a store with B. So this is pushing array the parameter on the stack. The next thing is we have to retrieve the member L from the structure that is pointed to by PTR. So to do this, we have register A already pointing to PTR because that's how we set it up earlier. So that's what we can do here. Now the other thing that we might want to do is to, I think this will be fine. So I'll let you know what to do. Okay, this is fine. I'm just thinking about optimization, and let's not worry about optimization. Okay, so anyway, A is PTR, which is pointing to a structure, which is also pointing to the first member of the entire structure, but that's not what we are interested in. L, according to the C code here, is the second member. So what we want to do is to access the second member. Because the first member only is taking up 1 byte, so the second member is 1 byte away from the beginning of the entire structure. So at this point, if I increment A, then A is no longer pointing to the beginning of the structure. Instead, it is the address of the L member of the structure pointed to by PTR, which is not what I want because what I want is the value, not the address of that thing. So that means I need to do an indirect like that, so that A is actually member L of the structure pointed to by PTR. And now we can push that on the stack. Like so. And then we need to push the return address. So I'm just saying traverse return from traverse L. And then we do decrement D, stda. This is pushing the return address. And now we are ready to call traverse recursively, which is really just a jump because we have set up everything else on the stack already. And now we have traverse return from traverse left as a label defined here. We can let's just increment the stack pointer twice to get rid of the parameters. I had some plan to reuse those things for later, but let's not do that because that's just optimization and it kind of adds to confusion. All right, so the traverse recursive call is now done. Next, we need to get to the value member of whatever structure that PTR is pointing to. Value is the first member, by the way. So at this point, because I'm returning back from a subroutine, I cannot assume any of the registers is retaining its value, except that D should be balanced at this point. So I'm just going to start with D again. Okay, so copy D to C again. And so C is now pointing to, it is the address of the return address. We increment C once. So the C is the address of PTR. And that's great, but that's not what I want because I need to get to the value of PTR. So we need an indirect. Okay. So now B is PTR, which is pointing to the beginning of the structure. But because value is the first member of the structure, that means B is also pointing to the value member of the structure pointed to by PTR. So because it is an address, so let me make it more clear. So this is also the address of um, the value member of the structure pointed to by PTR. So one more dereference, and we get to the member itself. There we go. So now B is actually the value member of the structure pointed to by PTR. So the right-hand side is done. We just have to figure out the left-hand side at this point. Register C is still pointing to PTR at this point, which means C is the address of PTR. So I increase C one time. C now becomes the address of array. That's not what I want. So let's do one indirection. So C is now actually array. But that's also not what I want. So let's do it one more time. So C is now the array dereferenced, which is also not what I want. But the next dereference is not going to be a load, because a load is using dereference to read. But because star array is on the left-hand side, I need to perform a write operation with a dereference in it. So this means we need a store in this case, and we're going to store whatever register B has. So now it is array gets PTR value, like that. So that line is now done. Moving on to the next one. And we can not depend on C anymore because I trashed C pretty thoroughly in the previous statement. Well, it's okay. Yeah, we can just copy it again. So CPRCD. So once again, C is the address of the return address. And then increment C. C is now the address of PTR. Increment C one more time. C is now the address of array. So we're getting closer to what we need. LDCC. So that C is now just array, which is also kind of close to what we want. And at this point, I have to be careful because I might want to get it back again. Okay. So at this point, we first have to retrieve whatever array points to, and I'm going to put it into a second register, a different register, so that B is star array. But we are going to add one to that thing, so we have to do an increment B, so that B is star array plus 1. But then we have to store it back to wherever we got it in the first place. So but that means we need a store instruction. And this completes star array equals star array plus 1. Because register C is array the entire time. So when we dereference register C, it is the same thing as dereferencing array. All right, so we are now almost done. We just need the second traverse at this point. Same thing, okay? So if we cannot remember what register C is pointing to, we can always just reinitialize it. Okay. And we need to get to array first. So let's do increment C. Okay, a little bit of comment here. So now C is the address of array. Let's do one dereference, LDBC. So the B is array, and that's what I need to push on the stack. So decremented stack pointer, std B in this case. So we have push array done at this point. Now we need to push the R member, which is the third member of the structure pointed to by PTR. We can decrement C so that C is the address of PTR again. And that's not what I need, so we need an LD instruction. So that now B is actually PTR. Now because R is the third member, I need to increment B twice because if I increment once, okay, let me make this more complete. So at this point, this is also the address of the first member of the structure pointed to by PTR. And if I increment B, it points to the next member. So the B is the address of member L of the structure pointed to by PTR. If I increment it one more time, then B becomes the address of the third member, R, of the structure pointed to by PTR. But it is still the address of what I need, so I need another indirect access. So B is actually now PTR points to R, or the R member of the structure pointed to by PTR. And I'm going to push that on the stack, like so. So we are pushing PTR points to R on the stack. And now we are ready to push the return address. So LDI, we can use B again or use A, doesn't really matter. So this is traverse returned from traverse right. Decrement D, push it on the stack like so. And then we perform an unconditional branch to traverse, which is the same thing as calling any other subroutine. We set up the parameters, we set up the return address, we perform an unconditional branch, and when we get back from the unconditional branch, the first thing we do is to clean up the stack because we have the two parameters or arguments still on the stack. So we get rid of those. And that's the end of the then portion of the conditional statement. We get to end if here. And now we just have to retrieve the return address, which is still pointed to by register D at this point because the stack should remain balanced at this point. So now we do a LDB. We can use A in this case because traverse is has a return type of void. And as a result, register A has no special meaning to the caller. But, since we're using register B for most things, might as well use it here. Doesn't really matter. Don't forget to increment D because we have to allocate the return address once it is retrieved. And now JMPB should return back to the caller. Now, whether the caller is another traverse or back to main really should not matter. Okay. So that should conclude the code. Of course, I haven't really done any testing here, which is kind of against what I preach in class. But we'll give it a try and see whether this works. And I need a different application to copy and paste it. So I'm going to use mousepad for that purpose. Here's mousepad. And we'll open that file. Oops, not new. We want to open. Keep pressing the wrong key. There we go. So we open from the temp folder. There we go. struct-1.ttpasm and Control A, Control C, and then we need to open up the assembler from shared processor and assembler. There we go. Go to the source tab, paste the whole thing, and go to RAM file. Oh, we got errors. Let's figure out what it's complaining about. Oh, there we go. So it's a LDI, not LD. All right, so good thing I got the checking done here. And let's see, no further error. I'm going to go to the RAM file. Everything's good. And we got file, download as. There we go. And we'll call this struct.csv in the temp folder. And now we can get Logisim into the view. And of course, it's a little bit big, and I need to fit the whole thing in. Okay, so that looks good. And we can just, oh, okay, it's a little bit too tall. Let me fit the entire thing into the recorded portion of the screen. Okay, just a little bit lower like that. There we go. All right, so let's first reset the processor. And let me load image. Oh, not TTPSM, it's CSV. All right, so we got the program loaded, and let's go ahead and run it. But before we run it, let's look at the memory locations, because if my program is running away, I can at least, type Control K here to stop it before it does any corruption. So Control K starts. There we go. Okay, it is not working. Well, that's good, because now I can kind of describe the debugging process. All right, so at this point, we know that FF1B, 1.5, those are pushed by main. And then FF1E, 3E is pushed by the first call. So everything still looks good, but this does not look good. It is using a 6.2 to load as the as PTR. This is array, which is the second parameter, and this is PTR, which is the first parameter. I also noticed that there's a 0.3 here, which means it got to the 0.3. It figured that the left branch is empty. It went back. That's how it put its 0.3 here. And then it attempted to go to the right branch. And as it tried to get to the right branch, it got to the wrong place and pushed 6.2 instead of one of the other valid nodes on the stack. So this tells me that the program is correct up to the traversal of the right branch. So the calculation of member R is not correct. So that has to be this code down here. We know it's pushing array just fine, so everything up to this point is good. So let's check, make sure that register C has array. Yep, that's how we got to array. When we decrement C, C becomes a pointer back to PTR. And then we get PTR itself by a load. And then we increment it once to get to L. We increment it one more time to get to R. And then we do one more indirect, so that we are not looking at the address of R, the member R, but we are actually getting to the value of member R. So all of this stuff looks okay. And then we perform the push on the stack. So nothing seemed to be wrong here. Let's check out and see if we can get other clues. So we got the FF62, and this is the return address of 3E. So everything is good up to this point. So the question is, where is it getting the 6.2? And you can see that it's repeating that pattern here, that it's pushing 6.2 on the stack. So we can also see that there's a whole bunch of DFs here at the beginning of the program. So it overwrote a portion of that memory as well. Huh, okay. Let's restart the whole thing. So do Control R. Oops, Control R. And reload the image again. And we take a look at the content. And then we start the code, Control K. Okay, so we can see how these locations are getting overwritten by this code here. And the corruption, FF1B15, that's from the first call, FF1E3E from the second call, and then FF62 is from the third call. And this is where the problem is, because I'm guessing this, let's see. Oh, so we are still exploring the left branch. Now, I know we're still exploring the left branch because the return address is still 3E. So we are still doing recursion on the left branch, but this is when PTR is supposed to be 0. It should not be doing it at this point. And so it is using location 6.2 as the beginning of a structure. And so this becomes the value. This becomes the right branch. Excuse me, this is the left branch and this is the right branch. So it's using location DF from here on to as the address of a node. Okay, so the problem is now at the conditional statement, checking that PTR is null, because if it is null, we are not supposed to go, we're supposed to return right away. All right, so let's check that. Okay, so we have C being the return address. C is now the address of PTR, and A is PTR itself. We test A, and if it is null, if it is a 0, we branch around the entire thing, go to endif, and over here we should be returning. So let's check the return code. The stack pointer should now be pointing at the return address. So B now has the return address. We increment D to pop the return address, and then JMPB to continue execution where it's supposed to go. Nothing here seems to be right. So just to be sure, I'm gonna get out of LogicSim and then restart LogicSim. There we go. And reload the program. And then we try this one more time. Okay, so we still have the same issue. FF1B15, FF1E, 3E, and then we have FF62, 3E. And as I said, these are all the left branch because of the return address. Okay, so let's double check and make sure that I didn't make a mistake when I specify the return address. So the second call definitely uses a different, ooh, look at that. This is decrementing C, it should be decrementing D. Okay, so maybe that's why, because it could have, hmm. So we know for sure that part is wrong. And let's see, let's change back to the browser. And then we go to the source, fix that one problem first. Okay, so this decrement C should have been decrement D because we're pushing the return address. All right, so let's double check everything here. C is the return address of the return address. C is the address of the pointer, and then A becomes the pointer. We check the pointer. If the pointer itself is 0, we jump to end if, and then otherwise we perform the recursive call. Okay, and then we go to run file, download it again, and then switch back to LogicSim, Control R, reset the whole thing, and then we load the image again. Okay. Go take a look at content. All right. So I'm looking at the content right here, and what I'm trying to do is to see if there's a 6.2 somewhere that is picking up. So I do see a 6.2 here. So it can be picking up the 6.2 from here. I don't think I can see a 6.2 anywhere else. So for some strange reason, it might be picking up 5C, 5D, and picking up the 6.2. And then 5D, just looking through the code here and see if there's a 5D somewhere. All right, so let's run the code. All right, so this time it is going in an infinite loop. All right, so with an infinite loop, let's check out the stack pointer. Stack pointer is a C6. And C6 is, this is C4, 5, and 6. So this is C6, which is a parameter. And okay, let's go back to the simulator and see if the stack pointer is getting changed all the time. Yep, it's getting changed all the time. And it looks like it got back to 0. Huh. Okay, so this is the first call, this is the second call, and here's the third call. The third call did not perform any further recursion, so that means it should be backing up again. But we are not seeing here, this location to change its value, which means we are not getting to the other side. All right. So we skip. So the left branch is working. We know that it can skip the entire thing because otherwise it wouldn't be jumping all the way back. And when it did go back, it would increment the stack pointer twice. Perform these two operations. Let's check the memory. And this time, CD is still pointing here, so we did not store a single value back here. So when we do return from main, excuse me, when we do return from traverse, it doesn't seem to continue execution from here. I'm just being stubborn and not use the proper debugging tool. But we can always put a halt instruction here. But this code was working before because we saw it's 3 there before. All right, so I think I'm gonna stop the streaming and get this fixed first, and then I'll do it again because it's hard to talk and think at the same time.